What's up, everyone? This is LeetCode 14, longest common prefix. So I've done this problem in Python, but now I'm doing it in C++. So we have to write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string, right? So you look at example 1, right? They all have the prefix FL in common, all these words. So FL is the longest common prefix, right? Of course, the third character is O, O, and I, so they don't have a common prefix for up to the third character. You look at example 2, none of these have any common prefixes in common, so just return the empty string. Okay, now let's look at the constraints here, by the way. You can see that at minimum, our array length is going to be 1, right? So that is a base case we can handle. So we're going to say if the length of the array is 1, just return the word, right? Because if our array of strings, if we only have one word in our array of strings, that word is the longest common prefix is just that word, right? Because I mean, what are you comparing it to other than itself? So in that case, the actual entire word would just be the longest common prefix. Okay, so that's just the base case we're going to handle. Now I'm going to show you an illustration of how we were going to conceptually think through this problem, okay, for our algorithm. So we have our first word here. This is going to be our checker, okay? And we're going to use this first word. This is example 1, by the way, all these words here. And this is going to work for any words, right? But meaning we're always going to just take the first word of the array. Given our array of strings, just take the first word, and we're going to use that to check against all the other words and find the longest common prefix. Okay, now we're not actually going to check the entire word all at once. We're going to check the characters. Okay, so this is how it's going to work. We're going to take our first word, and we're going to take the first character. Okay, F. Now let's go to the second word and take the first character and check these. Okay, they match. Nice. Now go to the third word, take this first character, they match. Nice, no problems. Now, in this first word, let's move over and take the second character. Now let's go to the second word, take the second character, they match. Nice. Go to the third word, take the second character, they match. Nice, no problem. Now, in this first word, let's go to the third character, grab this O. Second word, let's go to this third character. Okay, grab this O, they match. Nice. Go to the third word, grab this third character, and they do not match. Now we have a problem, right? We need to terminate our algorithm. And when we terminate our algorithm, the way we're going to return our longest common prefix so far is using the first word, we're going to return from the start of the word up to, but not including, the current character, right? So we'd return FL. And of course, as you remember from example 1, FL is what we should be returning. So that's how our algorithm is going to work, okay? There's also another thing that can break our algorithm that we have to handle. And that would be a case where we're out of bounds, right? For example, right, grab this F, compare here, we have this F here, nice. Grab this F here, nice, no problem. Move over, grab this L, okay, go here, grab this L, no problem. Grab here, grab this L, no problem. Okay, now let's move to the third character. We grab this O, go to the second word, grab this O, no problem. When we go here though, right, we're out of bounds. Okay, we're out of bounds. So the way we're going to do this is basically, as we're moving, okay, when we're moving along the first word, right, we have an index, right? I is equal to 0 when we're at this F. I is equal to 1. I is equal to 2, right? And the way we're going to know if we have a word out of bounds is we're going to say, is I equals to the length of a, my handwriting is not good when I have to actually draw it like this, but when the index is equal to the length of a word, that's when we terminate and just do the same thing, up to but not including the I, right? So for example, this third word here, right, the length is 2. So when we're here at this O, I is equal to 2, right? So 2 is equal to 2, right? So we're going to return from I is equal to 0 up to, but not including, or sorry, we're going to return from the index 0 up to, but not including I, right? So in that case, this is up to, but not including I, so we'd return up to, but not including, and again, I is 2 in that case, in this case, right? So we would be up to, but not including this 2, and so we'd return here. We'd return FL, right? Even though we're out of bounds, you see how we're still grabbing the proper longest common prefix, right? So those are really two important conditions we need to check to make sure that we don't run into any problems, okay? So I hope this illustration helped. I know this problem's a little bit hard to kind of, at least mentally, kind of wrap your head around, which is why I think these illustrations help a lot. So I hope this helped. And now let's actually get to the problem. Okay, so let's go through the first word, right? This is the first word that we're going through. Plus plus, right? And let's just grab the character at a given index I, right? When we're at when we're iterating through the first word, we need to actually grab the character so we can check that character against the other characters of the other words, right? So we're gonna say go to the first word and grab at the ith index the character. Okay, nice. Now here, right, is where we're going to iterate through the words. So what J is basically going through. J is going to be set to 1 because we don't want to compare flower to itself, right? We want to compare flower to flow and flight. So J is going to be actually set to 1, and we're 1 up to the end of the array of strings, okay? So J is equal to 1. J is less than strings size J plus plus, right? We're going to say if I is equal to the length of whatever word we're on, right? That would be the case where like I is equal to 2 and the length of the word is 2, right? Like FL, for example, if that's the entire word, right? Like that second condition I was showing you that would break our loop. That's what we're checking here. So if I is equal to strings of J at the length of some word, right? That would be a condition where we would break. Another condition where we would break is if the characters don't match, right? So C is not equal to the actual character. So let's go to the word J and grab the actual character. So go to the word J and go to the ith index. Okay. So those are the conditions where we would break. So we'd return, grab the first word up to, and we would grab from the start of the word up to, but not including I, right? And that should be fine, right? Now, if we exit this loop and we don't return in here, it means we could have like 3 words. We could have like 3 words and they all have the same common prefix. And that'd be a case where we would want to return. I mean, I can just show you here. We do need a return statement anyways, so. Sorry. Guess this goes here. That is a mistake by me. Right. I mean, you need to have something there anyways, because this is obviously nested in a bunch of for loops, but I mean, technically, I guess you could have words that are all the same anyways, but yeah, just keep this here. I mean, I guess you could have like a flag here and just set like a permanent value and then use that to return down here, but I don't know, it's just a lot of work. I just like this because it's more concise in terms of what is actually breaking your algorithm, but I mean, you can approach this problem in various ways. This is just one of them. And really, I structured this solution in a way where it's like very obvious what you should do and what we're doing and what we're checking. But again, like I said, you can kind of approach this problem in various ways. Really up to you if you can think of another solution that makes more sense to you, that's simpler to remember and kind of understand. go for it. This just worked for me, right? So I hope this helped, and I'll see you in the next one.